Today we're going to talk about solving systems by graphing. We have a couple of vocab words. System of equations. It is two or more linear equations. It doesn't necessarily have to be linear. It can just be two or more equations, but today we're going to look at linear. A solution is a set of values for the variable that makes all equations true. So if you remember from Algebra 1, you were given an equation like this one, so 3 equals negative 2x minus 7. And you were told to solve. Well, you would do some inverse operations here. And you would get a solution, okay, where x is equal to negative 5. Graphically, I want to show you what this means. We can take each side of the equal sign here. So we can take the left side and the right side and make them each an equation. So I can have y equals 3, and I can have y equals negative 2 minus 7. If I graph those two equations, so y equals 3, that is a horizontal line. And then y equals negative 2x minus 7. So I'm going to start at negative 7 and go down 2. So watch my scale because it is, I am going by 2's. So I go down 2 and to the right 1. I can also go up 2 and to the left 1. Okay. And if I continue in this way, I will eventually get a solution. Okay, I will have a point there where the two lines intersect. And that x value right there is x equals negative 5. So that's what this means graphically, and so we're going to look at more examples. First, let's look at the types of solutions that you can have. If you have two graphs that intersect at one point, that is one solution. Okay, and the solution is where those two graphs intersect. If you have parallel lines, you have no solution because the two graphs never intersect. Okay, so this is parallel lines. And then you will have an infinite number of solutions if the two graphs are the same line, because they will intersect each other at an infinite number of points. So let's look at this one example here. We are going to solve this system by graphing. So the key to this is it needs to be in slope-intercept form, so it needs to be in y equals mx plus b, and which these are. So the first one here, I am going to start at negative 6. I'm going to have to do a different color here. At negative 6, and I go down 5 and to the right 3. So I am off my graph here. But I can also go up 5 and to the left 3. Okay, so I can draw my graph here, and it's not going to be perfect because I don't have a ruler. Okay, so there's my first line. I can draw my second line. I start at 5 and I go up 1 and to the right 6. So I'm right there. I can also go down 1 and to the left 6. Let me extend this line here. And you will notice that these graphs intersect at this coordinate point here. And that coordinate point is negative 6, 4. That's your solution. One more example here. these equations are not in y equals mx plus b. So we have to get them there. So let's start with 6x minus 5y is equal to negative 45. So I am going to get rid of the 6x. So I have negative 5y is equal to negative 6x minus 45, and then divide by negative 5. So I get y is equal to 6 over 5x plus 9. So that's my first equation, so I'm going to start graphing it. I start at 9, and my slope is 6 over 5. So I can, instead of going up, because I'm going to run out of room, I can go down 6 and to the left 5. So right there. That's not a very good line. Let me try that again. Okay, I think that one might be worse, but you get the idea. We can also do this with the second equation. We need to get it into y equals mx plus b, so I'm going to subtract 2x. 2y is going to equal negative 2x minus 4. Divide by 2 on both sides. You get y is equal to negative x minus 2. So I'm going to start at negative 2, and I have a slope of negative 1. So I can go up 1 to the left 1, and down 1 to the right 1. Okay, so if you notice, my solution is right there. That coordinate point is negative 5, 3. So that's my solution. Okay, I'm going to show you this one now. So again, we got to get this into slope-intercept form. So the second one is already there, but I'm going to go ahead and get the first one there. So I'm going to subtract 3x. I get 6y is equal to negative 3x minus 12. Divide by 6. So y is equal to negative 1/2 x minus 2. Okay, so I'm going to graph this one here. So I start at negative 2, and I have negative 1/2 as my slope. So I go down 1 to the right 2, or up 1 and to the left 2. So I have a negative slope here. Okay, so there's my line. Now I'm going to graph the second equation. I start at negative 5. My slope is negative 1/2, so I go down 1 to the right 2, or up 1 and to the left 2. Now if you notice, these graphs, these lines are parallel. If they are parallel, we have no solution. Okay, and also the way to tell this without graphing is look at the slopes. You have a slope of negative 1/2 in both. That means that they're parallel. Last example here, I have negative y is equal to negative x minus 6, so this needs to be in y equals mx plus b. I just need to get rid of that negative. So I am going to divide by negative 1 on both sides. So that just changes the sign of everything. So I have y equals x plus 6. This second graph here, I just need to get y by itself. So I can divide by 3, and I get x plus 6 is equal to y. And you can actually change it around to be y equals x plus 6. So if I graph these, I start at 6, my slope is 1, so I go up 1 over 1, or down 1 to the left 1. Now, this is the same equation. Okay, for both equations up there, we have the same line. So the solution set there is an infinite number of solutions. Okay, so one thing to remember is if the graphs intersect at one point, it is one solution. If you have parallel lines, you have no solution, and then if you have the same line, you have infinite number of solutions.